You know what's mind-blowing? Every time you load a web page, your data travels through an invisible maze of routers and switches, making split-second decisions that would put the most sophisticated traffic control system to shame. Today on Technically You, we're pulling back the curtain on the protocols that make this digital dance possible.
That's such a fascinating way to think about it. These hidden systems that handle trillions of data packets every day without most people even knowing they exist.
And what's really interesting is how these protocols, ISIS, OSPF, and MPLS, each evolved to solve different pieces of this massive networking puzzle. The story of ISIS is particularly fascinating because it wasn't even originally designed for the internet.
Oh, really? Where did it come from then?
Well, ISIS, or Intermediate System to Intermediate System, is a link state routing protocol designed for efficient data transportation within a computer network. It was actually created by Digital Equipment Corporation for their own network system called DECnet. But here's where it gets interesting. It was so well designed that it became a cornerstone of modern internet infrastructure after later adoption by the IETF for TCP/IP networks. It operates at layer 2 of the networking model, which makes it incredibly versatile.
So it's like having a universal translator that can work with any type of network traffic?
Exactly. And this is where we see some key differences between ISIS and OSPF. ISIS has this fascinating hierarchical structure using different levels of routers. Level 1 handles local routing, Level 2 manages the backbone, and Level 1-2 routers connect these different areas together.
That reminds me of how cities organize their transportation systems. Local streets, highways, and those crucial connector roads that tie everything together.
That's a perfect analogy. And just like how cities need different types of roads for different purposes, networks often need different protocols. OSPF, or Open Shortest Path. First is a widely used link state interior gateway protocol IGP for routing IP networks within a single autonomous system. For instance, it was specifically designed for IP networks and uses what's called areas instead of levels, with Area 0 serving as the backbone.
How do these protocols handle network changes or failures? That seems like it would be crucial for keeping everything running smoothly.
Now, this is where it gets really interesting. Both ISIS and OSPF use something called Dijkstra's algorithm. Think of it like having a real-time map of the entire network. When something changes, every router quickly learns about it and recalculates the best paths, kind of like how your GPS reroutes you when there's traffic ahead.
That's fascinating. And then we have MPLS, or multi-protocol label switching, Xerania, which seems to take a completely different approach.
MPLS is like adding express lanes to our network highways. Instead of making routing decisions at every hop, routing decisions are made only at the network entry point. .MPLS creates predetermined paths through the network called label-switched paths, leading to faster and more reliable service. It was developed in the late 1990s to address inefficiencies in traditional IP routing.
You know what's interesting about MPLS? There's this common belief that it's inherently more secure than other networking approaches.
That's actually a huge misconception. While MPLS provides logical separation of traffic using labels, it's not inherently private or secure. It's more like having dedicated lanes on a public highway. Your traffic is separated, but it's still running on shared infrastructure.
That must have significant implications for how organizations approach network security.
Absolutely right. This is where modern approaches like SD-WAN, software-defined wide area network, come in. SD-WAN can leverage various underlay technologies for connectivity, either Ethernet, wireless, internet, or even satellite. Many organizations now use a hybrid approach, combining MPLS with other technologies to create more flexible, secure networks. And here's something fascinating. Many SD-WAN solutions actually still run over MPLS networks.
Looking at how all these protocols work together, what would you say is the biggest surprise for most people?
I think what surprises most people is the sheer scale and complexity of what's happening behind the scenes. Every single time you load a web page or send an email, these protocols are working together to find the most efficient path through a network that spans the entire globe.
That really puts things in perspective. These aren't just abstract technical concepts. They're the foundation of our modern digital world.
And what's even more remarkable is how resilient these systems are. They handle billions of connections every day, automatically routing around failures and congestion, all while being constantly updated and improved. It's like having a self-healing, self-optimizing transportation system that operates at the speed of light.
So what should our listeners take away from all this?
I think the key takeaway is that while these protocols might seem technical and abstract, they're actually the invisible infrastructure that makes our digital lives possible. Understanding even a little bit about how they work helps us appreciate the incredible engineering that goes into keeping us all connected.
What an amazing journey through the backbone of our connected world. Thanks for joining us today.